All right, so we're going to be spending the next 3 days talking about how to solve a system of equations that has 3 variables in it. So we've been focusing on systems that have 2 variables, x and y. When we're doing the 3 variable ones, so we're just going to be focusing on ones of the linear type. So this first one we're going to look at, so this top equation has x, y, and z in it. And we can see the second one has y and z. So when you're solving a 3 variable system, the first thing you want to look for is to see if there are any of the equations that just have 1 variable in it. So for example, this last one, we are given that z is 2. So all we have to do is work backwards here, and we should be able to pretty easily use substitution to figure out all of our other variables. So we'll take this second equation here, and we'll make it y equals 2 times 2, or y plus 2 times 2 equals 0. And so then we would have y equals -4 when we move that over. And we know that z is 2, so then we can come back up to that top equation and plug everything else in. So x plus, and then 2 times -4 would be -8. So you could have just made that -8 as well. And then plus 3 times 2, which is 6, equals 6. We'll combine like terms, so x minus 2 equals 6, which is going to make x equal to 8. Okay. And when you write your answer to a system that has 3 variables in it, we're going to write it as what's called an ordered triple. So we will write all of our variables in alphabetical order, and we'll write it just like an ordered pair, except they're going to be 3 points. So 8, -4, 2 would be my final answer. Okay. And you can plug the points back in just like we could with any others to make sure we have the correct answer. So that would be 8 minus 8. So that's what that would be. So that would be 0 plus 6 gives us 6. So we're good with that one. -4 plus 4 is 0. And then we were given that z is 2. So we know that that's the correct answer. Okay. All right, so we'll do the same thing in this one. My first equation has x and y. My second equation has y and z. My third equation just has z in it, so that's where I'm going to start. Okay. All right, so when I take 540 divided by 5, I'm going to get z to be 108. And then we'll just look for where we can plug that back in. So my second equation is the other equation that has z in it. So that will become y plus 108 equals 180. And then 180 minus 108 is 72. And then we'll take that value of y and plug it back in up here. So x plus 2 times 72 is 144. And then 180 minus 144 is going to be 36. And so my ordered triple for that one would be 36, 72, 108. All right, why don't you pause the video and try the next problem on your own. Okay, all right, let's see how we did. So as I peruse through my equations, I've got all 3 in the first one, 2 in the second. Here again is just 1 in the third. So I can pretty easily see that z is going to be equal to 4. From there, we'll figure out where to plug it back in. So we're going to work back again. And this isn't always going to be like the third, then the second, and then the first. So always make sure you look at all 3 equations and kind of come up with a plan first. So then I can come to the second one. So 3y minus 4 equals -1. Add that 4 over. And then y is going to equal 1. And then I can plug y and z back up into that top one. So x plus 2 times 1 is just going to be 2, plus 4 equals 9. Well, that's going to be x plus 6 equals 9. So x is going to be 3. So my ordered triple here would be 3, 1, 4. Okay, so all three of the examples we just looked at were ones where one of the variables was either given to us directly, like this one, or equations that were pretty easy to solve for one of your variables. So the next couple examples that we're going to look at are ones where we have to kind of create a new system. So I see in this first equation and the second one, all three variables are given to me. This last one, while it has two variables in it, this is what x equals. Okay, so what I can do still is now take that value for x and substitute it back into both of those equations. So when I do that, so 3 times negative 3z plus y minus 2z equals 22. Okay, and I'll simplify that to negative 9z plus y minus 2z equals 22. And then finally combine these two z's. So I would have y minus 11z equals 22. Okay, so here is that top equation once I substituted x back in. And I'm going to do the second thing in the same thing in the second equation. So when I plug x in here, that would give me negative 3z plus 5y plus z equals 4. And then when I combine my terms here, I'd have 5y minus 2z equals 4. So what I did is I took what was defined for me. So x was given just with a variable in it. And I created now two equations with two variables. Okay, so you kind of want to look for a hidden two variable system. So now what we can do is we can take these two equations and line them up. Y minus 11z equals 22 and 5y minus 2z equals 4. And now we've just created a system like we spent several days last week solving. So you can either use substitution or elimination. I'm going to go ahead and multiply my top equation by negative 5, I think. And then that'll allow me to cancel the y's. So negative 5y plus 55z equals 22 times negative 5 is negative 110. And then when I add down, my y's are eliminated, and that's going to give me 53z. Negative 110 plus 4 gives me negative 106, which gives me a z value of negative 2. Okay, and then I can come back up to either one of these equations now to get my y value. So I'll use this first one here. So y, negative 11 times negative 2 would be positive 22. And then when I subtract that over, that gives me a y value of 0. And now I have to go back and I still have to find x. And you can use any equation, but this one's definitely going to be the easiest because x is already by itself here. So when I plug in x, negative 3 times negative 2 is positive 6. So my order triple would be 6, 0, negative 2. All right, so we can double check our answer. The ones that are more work like this, you might want to just plug in just to be sure. So 6, 5 times 0 is 0. Z was -2. Okay, we're good with 4 there. And then this one, so 3 times 6 is 18, plus 0 minus 2 times -2 gives us 22. So we're good. We know we got the right answer. That looks like a sad smiley face. There we go. All right, and so here's my last one. Oh, sorry about that. So my last system is a little bit different even than the one we just did because none of the equations have a variable defined for us. But when I look at these, we always want to come up with a plan first. So I see all 3 variables in this one. These 2 each only have t and s in it. So I've got that, again, that hidden 2 variable system that I can use to solve just for s and t, and then I can come back up to that top one and solve for r. Okay, so I am going to just change the signs of maybe this middle equation here so that my t's will cancel. So make that negative, that positive. So now my t's cancel. It's going to give me -4x equals +4. So s is going to equal -1. And then when I plug that back into either equation, maybe I'll do that second one since I kind of wrote all over that first one. So t -3 times -1 is going to be +3. So t is going to be -2. And then when I plug everything back into that first equation, 5r, -4 times -1 is going to be +4. -3 times -2 is going to be +6. So 5r plus 10 equals 3. So 5r is going to be equal to -7. And then -7 divided by 5 would be -1.4. Here's a case, and we've talked a little bit about this in a couple of different scenarios with our systems. When your answer is like an exact decimal, right? We need our answer to be precise and exact. So if I were to take, -7 divided by -5, I get -1.4. So it doesn't really matter whether that answer is a fraction or a decimal, but had that been the other way around, 7r equals -5, if you were to type that in your calculator, -5/7, you get that decimal, right? That's not a precise, that's not an exact decimal. So that is when we would need to make sure we leave our answer as -5/7. Now, when we write our answer to this one, since it's not X, Y, Z, that's okay. We just have to make sure you write your answers. When you write it, you'll write it in alphabetical order. So Q, R, S, T. So -4, -1, -2. Okay, and that's an answer too. You can always check. Some people are uneasy when our answers turn out to be decimals, but when we plug everything back in, so if I start with that first one, so 5 times -1.4 minus 4 times -1 minus 3 times -2, fingers crossed, gives us 3. And then t, so -2 minus 1 is -3, which is what that started with. And then -2 plus 3 is 1. So we're good. All right. So tomorrow we'll look at kind of the next level here when all 3 equations have all 3 variables and how we will work around